what I see? I see that when I have a positive exponent, it's on the top, and when I have a negative exponent, so a positive exponent is in the numerator position, a negative exponent is in the denominator position. Okay? So what does this mean? What this means is when I have a negative exponent, what I'm going to do, a negative exponent is a reciprocal. So a negative exponent, of course my pencil would run out of lead now. A negative exponent, click, 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 okay, there we go. Exponent is a reciprocal. And if you recall, a reciprocal is that flipped fraction. So the reciprocal of 2 is 1 over 2. The reciprocal of 1/3 is 3 over 1. The reciprocal of 4/5 is 5 over 4. So if what I could say is 2 to the negative 1 is 1/2. 1/3 to the negative 1 is 3 over 1. 4/5 to negative, well, 4/5 to the negative 1 is 5 over 4. Okay? So whenever we talk about a negative exponent, we're talking about taking the reciprocal. Okay? So let's take a look at some examples. I expect you to have this written down, and I expect you to do these examples with me. Okay, so let's take a look at some examples. Okay, so first of all, let's try this. Let's start with an easy one. Okay, 1 over x to the 5th. If I wanted to write that with a negative exponent, I would write that as x to the negative 5th. Okay, let's take it in the other direction first. Okay, let's say I had y to the negative 6th power. Okay, so when I think about negative exponents, I think of the song Should I Stay or Should I Go by The Clash. We'll listen to that in class tomorrow. Should I stay or should I go now? I'm sorry you had to listen to that, but that's what had to happen. Because if you stay, it could be trouble. If you stay, it could be double. I don't know the words, but there it is. So when I look at a negative exponent, anytime I look at an exponent, it means it can't stay where it is. It's got to go. Okay? So right now, if I wrote this, remember, we talked about the invisibles yesterday. We have the invisible exponent, the invisible coefficient, and we have the invisible denominator. So y to the negative 6 is written as y over 1. Okay? If I want this to go, it has to go to the bottom. That's how I get rid of the negative. And if there's nothing up there, I put a 1 on top. Okay, let me try another example. Let's say I have 3 to the negative 4th power. That means right now, this 3 is on the top. It has to move. It can't stay where it is because it's negative, and I'm not allowed to have negatives in my final answers. So if I want it to move, if I want to get rid of this negative, I have to move it away from where it's at. So instead of being 3 to the 4th on the top, I'll have 3 to the 4th on the bottom. This also works when the exponent is on the bottom. So if I had 1 over x to the negative 6, let's say, well, does the 1 get to stay where it is? Yeah. So the 1 can stay up there. Does the negative x to the negative 6 get to stay where it is? No, because negative exponents tell me it has to move, it has to go somewhere else. So it can't stay on the bottom, it's got to go to the top. So it becomes x to the positive 6. And there's nothing left on the bottom, so I put a 1, which means that's x to the 6th. Now all of this is work that we may not end up having to show, but that's kind of like just thinking about what we did. Okay, let's do a couple